Hello class, today we're going to talk about scientific notation. So by the end of this video, you need to be able to do two things. Convert any standard notation number that I give you, whether big or small, into scientific notation. And if I give it to you in scientific notation, be able to convert it back to standard form. Well, in order for us to do that, we have to have a prerequisite skill, and that is we have to understand exponents. So we've got 3 to the 4th power. Well, what does that really mean? Well, 3 to the 4th power means that I need 3 times 3 times 3 times 3. I'm going to multiply 3 by itself 4 times. Okay, so we would type this in on the calculator. 3 times 3 times 3 times 3. Or on the calculators that we have a little button that looks like this. This is called our exponent key. So if we were to type in 3 and then press this button and then the 4, we would end up getting an answer of 81. So that's the way we type in exponents on our calculator. Okay, so 4 to the 3rd power. If we did that one, we would get 4 times 4 times 4, because that means 4 times itself 3 times. If we were to type that one in, we would get 64. So if I have a positive exponent, that basically means I'm multiplying. Well, a negative exponent is a little bit different. Okay, if a positive exponent means that we're going to multiply, a negative exponent means that we're going to divide. So in essence, this 3 to the negative 4, what it really means is I'm going to do the 3 times 3 times 3 times 3, but I'm going to do it under the numerator of 1. So we're going to divide by that value. So if we were to type this number into the calculator, you should get 0.01234567 because it did round here at the end. There is an 8 there, but the next value would have been a 9, so it rounded the last value on the calculator. Okay, same thing for 4 to the negative 3. What this one really means is 1 divided by 4 times 4 times 4, which gives us a value of 0.15625. Okay, so the one thing I need you to understand about exponents is if I have a positive exponent, I'm going to multiply. If I have a negative exponent, I'm going to divide, and that will become very important in our lesson today. So let's talk about scientific notation. Scientific notation is just a way to write very big or very small numbers in an easier way. So the way we write that, there is a format that we're going to write. We're going to have a particular number here in the front. This number in the front has to meet a certain standard. It must be between the values of 1 and 10. Okay, so it's got to be greater than or equal to 1, but yet less than 10. That's what this number right here needs to be. Then we're going to do times 10, because when I multiply anything by 10, whether it's with a positive exponent or a negative exponent, it's going to move the decimal either to the right or to the left. Positive exponent is going to move it to the right. Negative exponent will move it to the left. So let's see if we can actually look at one. Okay, so here is a particular number. This number is written in standard notation, and you'll notice it's rather large, and it has a lot of zeros. Well, the purpose of scientific notation is to write a number in such a way that I don't have to write out all those zeros, but yet it has the same value as that number. Okay, so I told you it had to be in a certain form, so what we're going to do is we're going to look at the number of significant digits. The 184 are what we would call significant digits, so we would write those down. And I need to be able to put a decimal into this number such that its value is between 1 and 10. So if I were to put the decimal right here, its value would be 184. If I were to put it here, it'd be 18. If I were to put it here, it'd be 1.8, which is where I want it. Or if I were to put it here, it would be 0.1, would not be between 1 and 10. So the only place I can put my decimal is between the 1 and the 8. And then we do times 10, because the times 10 is what moves our decimal around, and that's the purpose of this. Move the decimal around so that I can write the number an easier way. Times 10 to the, and then we're going to put an exponent here. Now the exponent is going to be the number of places I moved my decimal in the number from standard to scientific. So in this original number, my decimal is here at the end, because if I don't see a decimal, that's where the decimal will be. And I moved it to between the 1 and the 8. So this exponent is going to be the number I have for the number of places I moved the decimal. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So I would have an exponent of 13. Thus, you see the number in scientific notation. Okay, so this first number, okay, we look at the significant digits. I place a decimal in it such that its value is between 1 and 10. And then I write times 10 to the, because that's what moves the decimal around. And then the exponent is not the number of zeros, but the number of places I moved my decimal. So let's see if we can practice a few of these. Okay, here are a series of numbers written in standard form that we need to convert to scientific. Okay, so the first thing we do is we look at our number and determine our significant digits. In this case, we have the 45. I need to put a decimal in the 45 such that its value is between 1 and 10. So could it go here? No. Could it go here? Yes. Could it go here? No. And those are the only three places the decimal could go. So it's going to go between the 4 and the 5. And then I write times 10. And now I need to figure out what my exponent is. To do that, I look at where my decimal was and where did I move it to. I moved it there. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So it's to the 11th power. Okay. For the next one, we do the same thing. We look for our significant digits. 2, 1, 5. Well, where would my decimal go? Okay, for it to be between a value of 1 and 10, it's going to go between the 2 and the 1. And then times 10. And then I look, where was my decimal? Where did I move it to? How many places in between? 1, 2, 3, 4, 5, 6, 7, 8. Okay, pause the video and you do the last one on your own. Okay, let's see how you did. Well, in this one we have 4 significant digits. So we end up with 9, 5, 4, 6. Okay, where does my decimal need to go? It goes between the 9 and the 5. Then I write times 10. And how many places did I move the decimal? Well, it started here, I moved it here. So there's 4 places that we move the decimal. So as you can see, this exponent does not tell me how many zeros are on the number. It tells me how many places I moved the decimal. So that's how we convert a standard form number into a scientific number. Now, can we go the other direction? What if I give it to you in scientific and say write it in standard form? Well, we know that the 1.34 is our significant digits. And we know that the times 10 is going to move the decimal. And the exponent tells me how many times to move it. Right now, if it's a positive exponent, we're going to move it to the right. So here I've got 1.34, and I need to move it 8 places to the right. So here's 1, 2, around the 34, and then I need to go 6 more times. 1, 2, 3, 4, 5, 6. For the empty places, we're just going to add zeros. Now I did this underneath my problem because where I write my answer, I need it not to have the humpy bumpy things. I need it to be a nice clean answer. So 1, 3, 4, and then I had 6 zeros. Throw in your commas, and now you have a good number, 134 million. We'll do the same thing with the 5.9 times 10 to the 5th. We'll write 5.9. Okay, this 5 tells me I'm going to move my decimal 5 places. 1, 2, 3, 4, 5, which means in this case I'm going to add 4 zeros. So we end up with 590,000, which is 590,000. Now the last one's kind of a silly one, but I did this one to prove a point. Okay, the exponent is not the number of zeros that we add. So in this case, it's going to tell me I'm going to move the decimal 2 places, and that decimal stays within the number. So we end up with 703.24, so just 703.24. Okay, and so that's how we convert scientific back to standard. Now that's using big numbers. Now what about small numbers? Well, small numbers are like this. It may be long, but they're still small. Okay, well, we do the same thing. So if you look at this one right here, we started off with 2 significant digits, the 45. Again, I need my decimal, or I need this number to be a value between 1 and 10. So I'm going to put my decimal between the 4 and the 5. We still write times 10 to the, but since this is a small number, instead of using positive exponents, we're going to use negative exponents. But the exponent is still found by the number of places I moved the decimal. So where was the decimal? It was here. Where did I move it to? Between the 4 and the 5. How many places is that? 1, 2, 3, 4, 5, 6, 7, 8 places. So it's a negative 8. Okay, so big numbers get positive exponents, small numbers get negative exponents. So let's see if we can do a couple. Okay, so here are some numbers written in standard form, and we need to convert them to scientific. So step 1, find your significant digits. Write them down. Place the decimal in your number so that that number has a value between 1 and 10. Okay, then write times 10 to the, and now we need to find out how many places did I move my decimal. So we look where the decimal was and where I moved it to. So 1, 2, 3, 4, 5, 6 places, so negative 6. Okay, so the next one, we have 307 for our significant digits. Where do I need my decimal to be? Between the 3 and the 0. And then times 10. And then we look, how many places did I move the decimal? Well, here's where it was. Here's where I moved it to. 1, 2, 3, negative 3. Okay. Now on this last one here, you'll notice that I only have one significant digit. And that digit is between 1 and 10. So I can write that as 9. So 9 times 10. Now where was my decimal? Right here. Well, where's the decimal at in the 9? It's actually right behind it. So how many places did we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have negative 10. Okay? So that's how we go from standard to scientific using small numbers. Now, last thing, how do I go from scientific back to standard using negative exponents? Well, when we did positive exponents, we moved the decimal to the right. So when we're going to do negative exponents, we're going to move it back to the left. So this time I'm going to write 4.8. Since it's a negative 6, I move the decimal to the left. You can remember that by the number line where the negative numbers, they're on the left. So I move it one place around the 4 and then 5 more places. Okay. And then for the empties, I add the zeros. So we write this as 0.00000048. So to me, these are the easiest ones because you always move it only one place around one of the numbers, and then you add the number of zeros that you need, which is one less than what the exponent is. So in this next one here, we've got 2.456. I need to move the decimal 4 places to the left. So 1, 2, 3, 4. Add in my zeros. So we end up with 0.000246. Same thing for this last one. Now, where is the decimal at in that 9? Again, if you don't see it, it's always at the end. So we need to move it 7 places. So 1, 2, 3, 4, 5, 6, 7. So that means I'm going to add 6 zeros to the front of this number. So 0.000009. So to convert scientific numbers or standard numbers, all it's a matter of is moving the decimal around. So if I've got standard form numbers and I need to write them in scientific, I write the significant numbers down, place the decimal in, count the number of places I move the decimal for my exponent. And you do that whether it is a positive exponent or a negative exponent. And that's all there is to scientific notation. Until next time.